Hello everyone. Today we will study about various hardware platforms which are used in IoT, various hardware things which are used to implement our IoT devices. In this lecture we will have some recap of some basics which are used in implementing various IoT devices related to some circuit theory. Like first one is Ohm's law, how voltage, resistance and current are interrelated. What is capacitor, inductors, what is switch, what is LED, etc. So what is Ohm's law? Ohm's law is nothing but it's when the volt in this V equal to IR. R stands for resistance, I stands for current, R stands for resistance. So more is the voltage, more will be the current. Less will the resistance, more will be the current. So voltage and current are directly proportional and resistance and current are inversely proportional. So V is directly proportional to R and I is indirectly proportional to R. And this is a circuit for implementing the Ohm's law, which is having the current is flowing of 10 volt in this resistance R, having the battery of voltage 10 volt. So this is an illustration of Ohm's law. Now what are capacitors and inductors? The concept used here is energy builds up in time. Capacitor builds up voltage. Voltage is stored in capacitor. It may be polarized or non-polarized. Inductor builds up current. Here the current is built. Here but in capacitor the voltage is the current is stored. Voltage builds up voltage. Capacitor builds up voltage, but the inductor builds up current. So this is the main difference between capacitor and inductor. They are most commonly used in filters, energy buffer stores, etc. Now what are switches and LEDs? Switches are you must have seen, these are just for the purpose of turns our electricity on and off. They come in many physical forms. Normally open anode versus normally closed. When the circuit is closed and when the circuit is open. So normally open and normally closed switches are there. And the next one is LED, light emitting diode. This is the diagram for diode, anode, and we are having anode and cathode. Anode is negatively charged, cathode is positively charged, and this is the diagram for light emitting diode. Like a bulb, here also it's like a bulb, but here the negative and positive charges, the polarity, that is the polarity matters. There comes in various different colors and sizes. Sometimes more than one, there can be more than one LEDs in the same package. So this was a brief discussion about switch and LEDs. Now next component is we have to do some coding to control the hardware. Now these are called programming systems through which the hardware is implemented with the help of various chips. Like there are various examples of programming systems. Some of them are as follows. First one, system on chip, SoC. It can be system on module. A module can be implemented also. MCU, this is the most common one. General purpose IO, GPIO, ADC analog to digital converter, over the air OTA, power on reset POR, brownout detection POD, watchdog timer WDT. So these are all programming systems on which we can code and we can implement our audio devices in an easier way. The example of these programming systems are wearable SoC and SOM, system on module and system on chain. Like these are wearable devices having smart bands and smart watches. These are all examples of programmable. Now we will take on SOC. This is the chip, is the programmable system which we can through which we can implement our every device, on which we have to implement our every device. ESP8266. It's having CPU of 32-bit and frequency of 30 by 160 megahertz. It's having RAM of 36 kilo and kilobyte kilo. Flash is of 4 MB, which is shared among different inputs and output devices. Different layout also possible. Input output is of 8 GPIO, 8-bit ADC, 8-bit ADC, PWM, and the network through which it is connected and the various technologies used are Wi-Fi and TCP/IP protocols, WPA and WPA2. Operating temperature should be -42 to 125 degrees Celsius. Power usage optimum is of 30 megawatt. ESP8266. These are all our lab modules through which we can implement. You can see in like Wi-Fi is written on the chip. The Wi-Fi is used to get connected this IoT device. These are all chips. It is having ESP8266, macro USB pins, buttons, LEDs, all are attached to this chip, and is having power specification of 3.3 volt. It is USB powered. It can be programmed in C or Arduino kit. With the help of Arduino kit, we can program it.